going to present a little bit of my dissertation research, which involves mainly the detection of explosives and illicit drugs using our invention, which is the novel planar solid phase microextraction geometry coupled to ion mobility spectrometry. So what is our research motivation? Well, as forensic scientists, we're constantly trying to find ways to improve the detection of explosives and drugs. But the methods that are developed must be rapid, so we can't slow down passenger screening or cargo shipments at ports of entry. It must be easy to use, easy to train on, low cost to implement. It must be more sensitive, that way we can sample larger areas such as rooms or cargo holds. So our research approach is unique in that we're improving the actual sampling and collection of odors. So here we see some suspected MDMA tablets, but it could really be any type of explosive or drug. So we subject that suspected sample to PSPME sampling. And here we see that it's a chemically coated substrate that collects odors onto itself. Now these odors have been identified as what come off of the drugs and explosives through canine trials and headspace analysis, a lot of which has already been done here at FIU. So once the sample is collected onto our substrate, it is directly inserted into the ion mobility spectrometer. Now many of you have encountered this instrument at airports, whereby they pull you aside for screening and swab your bag or place you through the air puffer machine. But we're different in that we're collecting the odors. So we put the sample into the detector directly, and we get a signal for the actual odor, and then that corresponds to an alert for the drug or explosive. So on the left, we see this fiber, and that's what's commercially available currently for sampling air for toxic chemicals. But here we see, represented as dots, are the volatile compounds that are emitted from the drugs and explosives. Now, what we have done is change the geometry from this tiny fiber into the planar geometry. And here we immediately see that we're able to collect more compound just by the sheer size and surface area. Additionally, we have improved the collection material in order to afford more capacity by giving more surface area, because each individual sphere gives you more surface area for collection. And the last thing that is very important is that with this new device, we do not have to create an adapter for the available ion mobility spectrometers, which actually our group was the first to be able to create that adapter for the fiber. So here are two examples of the vast applications of PSPME. On the right, we see an example of a sampling of ecstasy pills. And we see immediately from the PSPME plasmagram that we see much larger peak compared to the commercially available fiber. And then on the left, we see an analysis of a small amount of TNT, 500 nanograms. And when we compare it to the amount that is recovered from the fiber, which is only about 30 nanograms, with our invention, we get about 140 nanograms. So that's a big increase in sensitivity and recovery. So we feel that the impact of this research is that it will improve security by providing a more sensitive method of detecting these drugs and explosives. It's in a way similar to how canines do it. And will also be real-time analysis in the field. Again, these detectors that are at airports are very fast. They do sampling in 7 seconds only. It is low cost, again, because we don't need to machine an interface to introduce our device. It can be directly inserted into the over 15,000 instruments that are conducting about 1 million analyses a year in airports alone, not to mention the ones for military and law enforcement applications. And again, as I've shown with the results, our invention is extremely sensitive. So I'd like to acknowledge the board, Mr. President, and the University Graduate School for allowing me to present this research, and all the student funding that I've received, my professor, Dr. Jose Almiral, and his other committee members. And I'd like to acknowledge the grants from the National Institutes of Justice and other private companies. Thank you very much.